All right. So we are going to take a look at, we're in section 9.1. We're going to obtain a point estimate for the population proportion. We've done this 100 different times and have had 5 different names for it. So this is something we've done before. Constructing and interpreting a confidence interval. We've done the math behind this before, but we didn't call it a confidence interval. So I'm hoping that it's not too confusing. So 9.1 leans heavily on some of the stuff we learned in 8.2. So we're going to be looking at proportions. We're going to use that new standard deviation from there. And so just so you know. And then we're also going to learn, determine the sample size necessary for estimating a population proportion with a specified margin. So we're going to look at sample sizes. We're going to look at confidence intervals. And I'm hoping this is something y'all pick up and are like, oh yeah, that's not too bad. I hope. I will do my best to get you there. So this is today. It shouldn't be a super long class because we're only covering one section. So we're going to do 9.1 today. We're doing 9.2 on Thursday. Next week, we will have chapter 10 both days. And then that's it for new material. So including today, it's 4 more Zoom meetings. And then all you have is your final test and your not final, but your last test and your final projects. So we are really in the home stretch. All right. So point estimate, we've done these before, and I think we might have even called them point estimate before. Point estimate is just p hat. So we're going to use this point estimate to estimate a value of the parameter. So we're going to estimate the proportion of people or things that have a certain characteristic. So as always, as before, this is what a point estimate looks like. So X is the number of individuals in our sample that has a certain characteristic, and N is the sample size. This is not brand new. We're just going to be using it again, and so we're defining it again. So point estimate, we called it relative frequency way back in the beginning. And so this is same old, same old. All right. So we're going to once again calculate a point estimate, and I lost my calculator. Hold on a second here. Okay, found it. It was hiding. So July 28th, Quinnipiac University poll asked 1,783 registered voters whether they favored or opposed the death penalty for persons convicted of murder. 1,123 were in favor. So what our point estimate looks like is 1,123 had that certain characteristic in favor of the death penalty out of 1,783. So we're going to math that. So that gives, that has me throwing my calculator. Sheesh, dropping it again. My goodness. Okay. 62, about 63%, 62.98. So approximately 0.63. So about 63% of the people, that's our p hat. So our p hat is approximately 63%. We've done this before. This is not new. I'm hoping you all are comfortable finding a p hat at least. If nothing else, we can all find a p hat, right? Okay. So a confidence interval. So based on our point estimate, we find a confidence interval. We're trying to estimate where the true percent of people, or the true proportion of people that have a certain characteristic. So we use the point estimate and we use the confidence interval because we don't know where the actual population value is. So basically, depending on how confident we want to be, we find our positive and our negative z-scores, and we build this confidence interval. And with that confidence interval, we can determine that the actual proportion is probably between those two numbers. So that's basically what we're doing. We're saying, oh, we're 95% sure, or 98% sure that the actual proportion of people that have whatever this characteristic is are between those two values. Our level of confidence, now this looks really scary right here. This looks really scary, but don't be scared. Basically, our level of confidence is like 95% could be our level of confidence, or 98%. But when we are doing a 95% confidence interval, it is the middle 95%. So if 95% is here, then 2.5% is here, and 2.5% is here. So we're basically looking for the z-scores that are at the top and the bottom of that interval. That is essentially what we're doing with our confidence interval. So this level of confidence here would be able to tell us what this value right here, this 95%. So I can say, I'm 95% sure, or I'm 98% sure. So we find these z-scores, and that will help us to determine, or we find those values if we have real numbers, and to determine how sure are we, or what does the actual value fall between. We'll do some examples and hopefully it'll help. So here's an example. So if I'm 95% confident, so that's basically if I created 95 different confidence intervals or 100 different confidence intervals with 100 different samples. So I took 100 different samples and did confidence intervals with all of them. 95% tells me that 95 out of 100 of those intervals would contain the actual population proportion. So let's say I took a sample and my p-hat of that sample is 0.63. The p-hat of the next sample is 0.68. And I keep doing that, and they're going to vary a little bit. And I'm going to build the confidence intervals off all of those p-hats. And so 95 of them would contain the actual population proportion. So that's how we determine how sure we are. Don't worry, you're not going to have to, you're really not going to have to explain all that back to me. I'm just trying to give you an idea of what that 95% confidence level means. Okay. So the way that we build a confidence interval is we have our point estimate plus our margin of error. You've probably heard margin of error before, right? We've all heard that. And I know that with elections and everything, they'll always say things like, this person is showing that they have 46% of the votes plus or minus 3. That means that their actual percentage could be somewhere between 43 and 49 if they were at 46. Plus or minus 3 means that there's this possible error of 3 above or 3 below. So that's what the margin of error is, and we're going to calculate that margin of error. And we get that margin of error based on how accurate our point estimate is. So we might have something like p-hat is plus or minus e. So I could say 0.63 plus or minus 0.06. So 63% plus or minus 6%. So that means that my actual value could be somewhere between 57 and 69. So it'd be somewhere between there. This would be the interval in which I could find my actual value. That's what that means. I'll give you a second. Right, moving on. So this is something, I believe that there's a question in your homework about this. So as my level of confidence increases, my margin of error is also going to get bigger. So if I have to be 99% confident, then my margin of error is going to be bigger. So just think about z-scores. A z-score for the 99% is going to be larger than the z-score for the 95%. So if I have, once again, so here's my 95% right here. then if I have a 99%, as you see, the distance from my p hat is going to be larger, which means my margin of error is larger with the 99%. So the orange is 99%, if that makes sense. So the interval within which the actual population proportion lands is going to be larger, the area that we cover. So if I have bigger sample sizes, my margin of error is going to decrease. So bigger sample sizes is going to help me get a smaller margin of error. That kind of makes sense because as my sample size gets closer to the population size, I'm going to get more accurate. And the more spread there is in a population, the wider the interval will be for my confidence. We don't really look at this one much. You're not going to see that in your homework. You might see one of these in your homework. You're not going to see the standard deviation one in your homework. I'd probably write it down, but I wouldn't worry about it too much. And all of this is going to make more sense when we start mathing it out. All right. We'll move on. Make sure you holler at me if I move too fast. Okay. We've been here before. That's why this has the little guy with the finger on his, the little string on his finger. So just as before, when we were doing sampling distributions, as I said, this draws on 8.2. It's approximately normal with our mu equals our p. So our p value, that whatever we're given, or our p hat, our mu is going to equal that value. We will use this to calculate the standard deviation. As we talked about before we started recording, when we're dealing with proportions, we use this for standard deviation because we're dealing with proportions. So we're approximately normal if NP times 1 minus P is greater than or equal to 10. And also, in order for the trials to be independent, we have to be less than 5% of the entire population. So this is all the review stuff from 8.2 that we're going to glom onto. Which I know some of you are still a little bit struggle busting with the 8.2 stuff. Hopefully this will firm it up a little bit. All right. We'll move on. Okay. The way we calculate a confidence interval for our population proportion, and I'm going to explain how to get the z-score in a minute, is you have your special z-score and you multiply it by the new standard deviation. So you take your new z-score, which don't worry, they're easy. They're not a hard thing to get. And I don't know why this decided to do funky things, but you take that new z-score and you multiply it by the standard deviation. You're going to subtract that from your p hat and you will add that to your p hat. And that will give you your confidence interval. So all this is doing is, it's like if I was looking for a value that was 2 standard deviations away from the mean, then I would just take my mean. Did this before, plus 2 times standard deviation, right? Isn't this how we found values that were 2 standard deviations above the mean? So remember here, our p hat is what we're going to use for our mean. The standard deviation is this right here. And this right here, instead of using just 2 as a z-score, whatever z-score fits our confidence interval, we're going to use that to multiply by the standard deviation. So this looks like a big new formula, but it's really not. We're just finding the value that is however many standard deviations away from our mean. That's all it is. And then I did this again. We're going to math it out. Hopefully, once we have numbers, it'll help. But this is margin of error. That's what that is. I guess I could write the words out. Margin of error. There we go. There's a weird writing of margin of error for you. All right. Move on. So this is just a picture of what I was explaining. We would find our z-score, and you multiply it by the standard deviation and add it to whatever your proportion is, which in this case, it's going to be p hat, because we don't know the actual population proportion. And then you do the same thing. You take your new z-score, which I'll show you how to get, multiply it by the special standard deviation, and subtract it from our p hat. And this will give us our confidence interval. This, I just took this picture directly out of the book. That's why it looks funky. All right. So this right here, this, I forgot that this part was on here. This z sub alpha divided by 2, this is called a critical value. It is the critical value because it tells you as far as your interval can go. It represents how many standard deviations you are away from the parameter, or away from your p hat, and still include the parameter. So it says I can be, 1.96 standard deviations away from that p hat and still contain my population proportion. So that's what that's telling you. This is called a critical value. We will use this critical value again once we get to our hypothesis testing in chapter 10, but this is called a critical value. I like the red on this. That's kind of like shiny. Sorry, I get distracted easy. It's the end of the school year. We get really distracted. All right. Let's move to the next page. Okay. So we have a table that uses the most gives you the most common critical values. This is on the bottom of your Z table. This one I got out of the book, but here's what it looks like at the bottom of your Z table. So if it's on the front page on the table 5, the very bottom right here, this is your most common critical values. All it's doing is finding the z-score that matches how much is in your tail. So for example, I'm going to give you a weird one. So let's say that I wanted to be 85% confident. So my confidence level is going to be 85%, which is a really weird percent. So 100 minus 85 is 15. So I have 7.5% here, and I have 7.5% up here, correct? Y'all with me so far? So that means this z-score right here is going to correspond with 92.5. This is the percent that's at that line. So that's the z-score I would look for. So since it's not located in this box, I could use inverse norm with 92.925, 0, 1, and I could get that critical value. But these ones are just the critical values they already found for you. So go ahead and use these if they give you one that's on that table, because why do extra work if you don't have to, right? But if you looked for those confidence intervals, they'd be the same thing if you put them in your inverse norm. So just figure out how much is in the tail and find the z-score that goes with it using inverse norm. There's another way, but I'm not going to make you do that, because I think we did it before where we looked in the body of the Z table and nobody liked that. So let's just not. Let's just not look in the body of the Z table. Is that all? We're all in agreement there? We don't want to look for that percent. Yeah. Because look, okay, I want a 99% confidence interval, or 98%. So I need 99.99. Well, I'm not going to find it on here anyway, but I don't want to have to look and find what lines up with it. Let's just not go there. Actually, it would. Let's see. That's 995. Yeah, let's not do it. Anyway, we're going to move on. Woo! That's just my whole thing, my whole desk area that I made out of weird stuff here just fell. All right. Here's the interpretation of a confidence interval. It indicates that of all, okay, that I'm going to say, like, if I had a 99%, I hate these words. If I had a 99% confidence interval, indicates that 99% of all my samples will result in an interval that contains the parameter. The parameter, remember, parameters are for populations. So this would be, this parameter is population proportion. I'm putting these words here because right now I'm assuming you guys are saying parameter. What's a parameter? Why are we looking for a parameter? The parameter refers to something to do with the population. So let's read it this way. A 99% confidence interval indicates that 99% of all simple random samples of a certain size from a population whose population proportion is unknown will result in an interval that contains the parameter. So if I create this interval right here, 99% of them, this is a 99% confidence interval, 99% of those samples will contain my population proportion. Now it could be over here. This could end up being my population proportion. Could be over here. It could be anywhere in here, but somewhere in here will be the actual population proportion. Whatever the actual value is will be somewhere in there. And so we're using our confidence interval to estimate that. If that makes any sense. Okay. Hopefully we're at math here in a minute. Let's take a look. Here we go. So Quinnipiac poll asked 1,783 registered voters and nationwide whether they favored or opposed the death penalty for persons convicted of murder. 1,123 were in favor. So we already figured out that our p-hat was 1123 over 1783, which was approximately 63%. Okay, we want a 90% confidence interval for the proportion of registered voters nationwide who are in favor of the death penalty. So I could either put 0.95 into my inverse norm, or I can go back here and I have my 90% right here. So I would use 1.645. So looking at your table is very smart because it's real quick. Okay, so I found my p-hat. I checked that NP times 1 minus P is greater than or equal to 10. It is. It's 415.6, so I think we're good. So the sample size is definitely less than 5% because of the whole population. We definitely don't have only, I don't know, 8,000 people. So our alpha, so alpha is basically 1 minus 0.9. Our alpha is 0.10. So when we cut that in half to get our tails, it's 0.005 or 0.05. So if I drew that, all it's saying is that there's 0.05 up here and 0.05 here. That's what this is saying, this alpha and this Z sub alpha. So if I was to do inverse norm with 0.05 or 0.95, this is going to be the Z score. We only use the positive Z score. This is what I'm going to get. Okay. So for my lower bound, I'm going to take this Z score right there, and I'm going to multiply it by the new standard deviation. Then I'm going to subtract it from our population proportion, which is our p-hat, or our p-hat, not population. Let's see, where's that math? Here we go. So this right here was the Z score. This right here is my p-hat. This is my sample size. So my lower bound, I took 0.63 and I subtracted this. My lower bound is right here. That's the lower bound of my confidence interval. So I'm going to do the same thing, but I'm going to add it to the population or the p-hat. So this right here is my p-hat. Once again, this is my Z score. And then my p-hats are right here. And my N is right there. And this is the top of my confidence interval. So this whole thing right here is my margin of error. That's the thing that I'm adding and subtracting from the p hat. We're going to do one by hand in a minute. And I know that those are usually more helpful. We'll do one by hand. All right. So I know that my population proportion, well, I'm 90% sure my population proportion is in here. I'm 90% sure that the actual number, the actual proportion of people who are in favor of the death penalty is between 61 and 65%. So we're going to go to the conclusion in a second right here. So this is what your solution, this is what your conclusion looks like. We're 90% positive or confident that the proportion of registered voters who are in favor of the death penalty for those convicted of murder is between 6.61 and 0.65. Because that was the values when I added that margin of error. Okay, this was just the first one. We've got another one. We'll get you there. So what happened was, right here. So this is my 90%, right? I'm going to kind of break it down. This is my 90%. So there's 5% down here and 5% up here. So I found my z-score at 0.95 is 1.645. That was my z-score. All right. So I took this z-score, I took my p hat, and I added this z-score times the new standard deviation to get this right here. And that's where I got that value. Once I added that to my p hat, which is here. And then I did the same thing, but I took my p hat and I subtracted the 1.645 times the standard deviation to get the bottom one. So all we're doing is calculating that interval. And then my population proportion should be somewhere in here, but I don't know where, but it's somewhere in between those two values. Okay, we're going to do another one. We'll get you there. All right. So we're going to do this one together. We're going to map this out and write it down together. So Gallup organization conducted a poll in which a simple random sample of 1,016 Americans 18 and older were asked, do you consider the amount of federal income tax you have to pay is fair? Out of 1,016 adults, 558 said yes. We want a 95% confidence interval for the proportion of Americans who believe that the amount of federal tax they pay is fair. I think everyone in here can get a p hat, right? We all can do that. $558 divided by 1016. So that's approximately, we're going to say that's 55%. Are we all good there? Okay. So remember, this is the confidence interval is the middle 95%. So even though I can look on my sheet, I'm going to use inverse norm with 0.975. That's not what I want. It is because I need 2.5%. 0, 1. This is going to give me my critical value for the z sub alpha divided by 2. So let's do that. Wait, 975. So that value right there, 1.96. Are y'all with me? Okay.
I have a quick question about the 0.975.
Uh-huh.
And so where did you get that again?
So if I have a 95% confidence interval,
Mhm.
if I bounce back to the wrong screen, so 95% is in here. So there's 2.5% here and 2.5% there. So that means this is 97.5 is where that is. That
Okay.
makes- yeah.
Yep. Got
Because
it.
we're looking at the center, right?
Thank you.
You're welcome. I bet you someone else had that question and just didn't answer it, so I'm glad you asked. Okay. Are we so far right where I am right now? Are we on the same page? Because all I did was use my inverse norm. We good? Okay.
Just wanted to let you know that on the slideshow printout, the whole
Uh-huh.
problem's blocked out. We just see the calculator functions.
Really? Ah, I'm so sorry. Okay.
So
Hopefully you can write it on there. We'll be okay. I'm gonna check that though. I'll check that and see if I can fix it. Thank you. Okay, next, I'm gonna calculate the standard deviation. I'm gonna calculate sigma sub p hat. So I have 0.55 times 1 minus 0.55 divided by my n is 1016. Trying to make sure to do it step by step so that we don't have the what the heck is going on thing happening, because I know that happens. It's okay. I don't know what I did. What did I do? Oh, I see what I did. I lost a decimal. Okay. I got approximately 0.156. Did we all get that? Are we there? Okay. So now I have the standard deviation and I have our z-score, which is our critical value. So way back when we were still just doing normal CDF and calling it good, when we were learning about z-scores, when we wanted to try to find a value at a certain z-score, you would take that z-score and multiply it by the standard deviation, right? We're going to do the same thing here. So I'm going to take this standard deviation and multiply it by that, or sorry, take this z-score, sorry, this is my z sub alpha divided by 2, take that critical value and multiply it by the standard deviation. So 1.96 times 0.156. Times, so I have approximately 0.03. You just found this right here is the margin of error. That right there is your margin of error. That right there tells you this is how far I can be away from my p hat and still be in that confidence interval. So I can write the answer depending on which problem you are on. I can write 0.55 plus or minus 0.03. This is one way to write it. The other way to write this would be to add this margin of error to 0.55, 0.58, then subtract this number from 0.55, 0.52. These are the two different ways to write it. So this is the p hat plus margin of error. And then this is just the interval with our lower and upper values. These are the two different ways you're going to be told to answer on your homework. Questions?
I mean, I feel like I have a lot of questions, but I don't even know what they are
Same,
yet.
literally same. I feel you.
I just,
Um,
I tried to step it down as much as I possibly could.
Yeah, no, I mean, and you're doing a great job teaching it. I get lost. I guess actually I have a question on so when you did the square root of the 0.55 minus
This right
what?
here.
Yeah. So when I do, what number is going into that? Like when I do the square root of
Okay.
0.55.
This is your p hat.
Mm-hmm.
And then this right here is your n, your sample size.
Yep. Okay. So hold on one second, because I was not getting the right number.
You might have needed parentheses somewhere.
Yeah, maybe. Oh, yep. I got it now.
We're good?
Yep.
Okay.
Thank you.
You guys ready for a fancy calculator function? No? You don't want a fancy calculator function that'll do all the work for you?
Yes,
I'm
yes,
all done.
please.
I'm done.
Okay, Kylie, you take a nap.
Okay.
You take a nap. I'm gonna give the rest of you a fancy calculator function. This
Okay.
one right here is going to do all the work for you. Even though I love doing it by hand, I don't know something about that, but we all know that I'm weird. So so it's okay. We know I'm weird, but we're gonna jump over to my calculator and I'm gonna walk you through the calculator part. The calculator part is super fast and simple, and I'm hoping that nobody will cry. Okay. I don't like to make people cry. I really don't. And I don't know, you think that I would have thought, if I don't want to make people cry, I shouldn't be a math teacher, but hey, here I am. Okay, I'm going to jump over to my calculator. If I can find my calculator, where are you? Aha, there we go. Okay. All right. So you're going to click on stat, then arrow over to test, and go down to one prop Z interval. It's down on the next screen. So it's one proportion Z interval. It's letter A, one prop Z int. And I'm going to hit enter. So my X value is the number of successes that I have, which is 558. Your N is your total sample size, which is 1016. And our confidence level here was 95. Make sure that you put 0.95 or everything's going to mess up and it's going to give you an error. So make sure you turn that into a decimal. That's it. This one's not complicated at all. All that information was pretty easy to get, right? I'm hoping, please. Now I'm going to hit enter.
Wait, so we do the,
Okay.
basically we're doing the p hat, right? So we take the parts per whole and then the percent that's in the equation.
Yep. The percent, that 95%, right? 0.95.
Okay.
Yes.
Thank you.
You're welcome. And then I'm going to hit enter. I'm going to get into there. So what this gives me is it gives me my p hat, which that's useful information. And it's going to give you your, it gives you your actual confidence interval. So ours was 0.52 to 0.58, but that was because of rounding. So, I mean, they're going to ask you to a certain number of decimal points, and this should work just fine for you. So I'm going to write this down on like my other screen here because I want to talk about this. Uh-oh, that's weird. I did something funky there. 1862 0.57981. Okay. So I'm going to go back to my other screen and we're going to talk about this. Look, it also gave you your p hat. So I'm on this screen now. So I have this lovely confidence interval here, but my question is telling me to write it in this form. Because this is going to happen. They might want this form on your assignment. Here's what you're going to do. First thing I'm going to do is put this in 0.52 to to 0.58 because it asked me to give it to 2 decimal places. So I'm gonna go along with what they said. So the p hat is the number smack dab in the middle, right? That p hat is smack dab in the middle of those two numbers because I just added the margin of error and I subtracted it. So if you do 52 plus 0.58 and then divide it by 2, that's going to give you that number smack dab in the middle, right? 0.55. That number smack dab in the middle. That's my p hat. All right, but I still need the margin of error. Can't I just take 0.58 and subtract my p hat to get that margin of error? I know I made it sound so easy, but basically you're just looking for the number smack dab in the middle. You're basically looking for the average of those two numbers, right? Just add them together, divide by how many there are. So if it gives you an interval like this, you don't have to say, oh no, I can't find my margin of error. Just average those two numbers that gives you p hat and then figure out how much was added to it to get that upper number or how much was subtracted from it. Questions? Okay. Calculator function's not really that scary, right? Maybe?
No. So instead of doing all of that stuff right there,
Woo.
we just do the calculator function.
Yep. Unless it asks you for the standard error, then you need to do this piece right here. Or if it asks you for the critical value, you need to find that. But I think you all could do each piece at the same time at one time. I think it feels like it's just putting it all together where I'm losing everyone. So if it asks you for the critical value, it just wants the z-score that corresponds with that.
Okay.
If it asks for the standard error, you're looking for your standard deviation. But yeah, you can just use your calculator and you'll find your p hat, you'll find your and that's the thing. Hold up here. Your calculator even gives you your p hat. So I could have just taken this number right here and subtracted the p hat from it, and that would have given me my margin of error, right? So that's even easier than what I did. You just subtract this p hat that it gave you from that number to get the margin of error. So bam, you got this.
And then do we add it to the other side?
Well, so it's already there. So I have both sides. This is if it wants you to give p hat plus or minus margin of error.
Okay, thank you.
Yeah. Okay. I'm going to get off the screen because it's scaring people. So I've already said this, but this formula right here gives you your margin of error. I already said this, but it was really messy. And so this is a nice, pretty new screen where you get that's the margin of error. And this is your critical value. And the p hat's already labeled, but this is a nice, pretty for your margin of error. So if you need the specific margin of error and that's all you're calculating, this is what you would use. Right, we can do this. I don't want to scare you when we go to the next thing. I really don't.
It gets worse.
No, it's really not that bad. It's really not that bad.
Is it possible to do at the end? I have a question on the homework regarding the margin of error.
Yeah.
Of
course.
Okay.
Of course.
Perfect.
Always.
Okay, thank you.
Always like office hours time at the end if we did it. It's no problem at all. All right.
I'm trying not to freak out.
No freaking out. You got this. Okay. Sometimes you have all the information, but you need the sample size. So the importance of being able to find the sample size is I might want a certain margin of error because I want my data to be pretty. Like, let's say I want to make sure that when I give the results of this poll, I want to make sure that my margin of error is no more than 2%. So I want it to look pretty. I want to be able to say, okay, this is, look, it's only 2% off. I don't want to get a huge margin of error. So I need to figure out what sample size do I need to take in order to get the margin of error that I'm looking for, or in order to get the confidence level that I'm looking for. So this formula right here will get you there. All this formula is I solved for n. I took that margin of error formula and I mathed it all up and I solved for n. That way you don't have to. It's less algebra for you. That way you're not solving, that way I don't give you like this. And then, oops, that should be it. Because it would be really terrible if I gave you this. And then I said, oh, solve for n. I have the z-score and I have, and like, let's say my margin of error is 0.02. And I have all those other values solved for n. That wouldn't be very nice of me. So instead, I solved for n for you and gave you, and it looks like a whole new formula, but it's just the same one reorganized. So the problem with this is we don't have a p hat because we don't have an n. Because remember, p hat is x over n. If we don't have an n, we don't have a p hat. So there's a way around that. Woo! And I just did it again. Okay. And I'm going to talk about what the way around that is. There's two different things I could do. If there was an earlier study, I can use that point estimate. I can use that p hat. So let's say 2 years ago, somebody else did a study and they got a certain value for their proportion. I can take theirs and say, okay, this is a great place to start. What kind of sample size do I need? If there's no other study, then I have to use the largest possible value of p hat, which, believe it or not, is 0.5. That's because 0.5 times 0.5 is 0.25. I'm not going to get anything bigger than that. So we will use that. If we don't have a previous study, use 0.5 for your p hat. All right, these are my two solutions, the only two ways that I can do this. Let's move on. All right. When we get our sample size, we have to round up to the next number. It's because, like, let's say that I got an answer that I said that was n equals 815.08. 815 isn't a big enough sample size to satisfy things because I need something more than 815. So I would have to round this to 816, even though it's really close to 815. Always round up with sample size. Always round up. Always round up for sample size. Next, the next integer. Always. Always, always. All right. Let's go to actually doing a math. That's just the same thing. All right. So sociologists wanted to determine the percentage of residents of America that only speak English at home. What sample size should be obtained if she wishes her estimate to be within 3 percentage points with a 90% confidence interval? She's going to use a previous estimate of this right here. That's our previous estimate. Oh, that's sweet. Thank you. Okay. So we're going to use that formula. So remember, it is p hat 1 minus p hat z alpha divided by 2 of e squared. Okay. My p hat is 0.824. 1 minus 0.824. Does everybody see where that number came from? Are we good? Okay. Oh, you guys are so sweet. All right. My z sub alpha divided by 2, you just put 0.95 in for your inverse norm. And I know what it is, but I don't really trust myself sometimes. And it's 0.95 because it's the center 90%. So it's 1.65. Oh, 645 divided by our margin of error, 3 percentage points squared. There we go. Now, before we do any math, I want everybody to look at this and see if there's anything questionable, any number you don't know where it came from. Okay, we're going to put the whole thing in the calculator. If you're not comfortable putting the whole thing, go ahead and piecemeal it. But I'm going to put the whole thing in the calculator. You should be fine with the parentheses where I have them. I got approximately 433.565. See if you guys get the same number I do. So I don't always trust my oh, nope, I got the wrong thing. Hold on. That's not right. Somewhere in here, somehow in here, I have a weird number. Okay, it's close.
I got 436.04.
Good, that's what I got. Yay! The first time I got the wrong thing because I put 0.825 instead of 0.824. So yeah, thank you, Caleb. All right, so we always round up. So we would need a sample size of 437. Always round up. It's kind of like if I'm taking a bunch of kids to, let's say I'm taking a group of kids to the movies, and each bus seats 50 kids. And I have 108 kids. And I can't go over my 50 kids. I have to get a third bus. Even though it's barely more than 100, I have to get that third bus. This is basically that. Questions? All right. Hey, look, they did the math also. I always forget when those are there. They got the same thing as us, so we're good. All right. I'm going to write the formula. I would like you to try this. So I'm going to write the formula again. So it's P hat times 1 minus P hat Z sub alpha divided by 2 over E squared. We are using a previous estimate of 10%. So your P hat will be 0.10. I would like you to try to find, because we're at what, 90% confidence. I would like you to try to find your Z score and try this. I'm going to give you a minute before I start doing it behind you.
Oh, get a napkin. Don't wipe on your.
Unless I put something in my calculator wrong, which didn't happen. So I have an answer there. So when you're done, go ahead and look up. You got it? Caleb got the same thing. Okay. Give y'all a moment.
You got the 0.02 from
Within,
2%.
yes.
Got it.
But where did you get the 1.645?
This is
I
my Z
lost you
score.
somewhere.
Whoops. This is my Z score. for the 90% confidence interval. So if you do inverse norm with 0.9501.
Oh, way back when, okay,
Yeah,
gotcha.
yeah. I just
So
remembered
how-
if that was our last,
Yeah.
on our last problem, we had that. And I grabbed that from there, but if you didn't already have that, you can get that from either the table 5 or you can get it from inverse norm. Other than that, are we okay? So now
Yeah.
it's- Yay! Okay. So now it says, what if the economist didn't use any prior estimates? So in this case, we would use 0.5 times 1 minus 0.5, which is 0.5, and do the exact same thing. And look, take a look at the difference. You will see really quickly why we like to use prior estimates. So go ahead and math that out. You will see so quickly that using a prior estimate is very good. So y'all can see that using a prior estimate is a much better idea. If you can find any kind of estimate previously, it's a great idea to use it because it just kind of gives you a starting point. Because generally things don't change so much that that a prior estimate's gonna steer you wrong. I mean, 'cause it's okay. So this said what 10% of people carpool to work. I'm thinking that probably the new proportion probably isn't hugely different. I mean, you might go up to 15% or down to like 7 or 8% or something, but it's not going to be 50%. So using a prior estimate is a great idea when you can. Questions? So
Wouldn't the 1691.27 just be 1691?
no, it always round up.
Okay, so it doesn't matter if it's an 0.01, you're gonna round up.
Yes, because 1691 wouldn't be enough
Gotcha.
because there's some left over. So we always round up.
Okay,
I
I just thought you meant the last numbers. Okay, gotcha.
always round to the next higher whole number. So I've seen in the past, I have seen people use confidence intervals in final projects. You do not have to. But if you took your own survey and if you just Google and say and find something online, like say you're looking at the percent of people, I'm just making stuff up, percent of people that drive red cars is 32%, and you have your own and you can be like, okay, so if I was going to do this, I could get a sample size. I would need to get this kind of a sample size to actually make a difference with my poll. You can do something like that. You don't have to. This is just things that have happened in the past. People have also used their own data and been like, out of the 50 people that I polled, 18 of them have this specific characteristic. So based on this, I'm 95% sure that the actual percent of the population would be between these two values. You can do that and kind of try to apply it to the whole population. You don't have to. Most people don't use confidence intervals, but it is something at least to keep in your mind if you're looking for things to do with your data. That was my last PowerPoint slide. I know somebody has homework questions. I probably should keep the recording on at least for a couple of homework questions. So what do we got?
So, hold on, let me find it. The first one I have is, it says in a recent poll, 240 people were asked if they like dogs and 17% said they did.
Yeah.
Find the margin of error of this poll at the 95%
yeah.
confidence level.
Is this in 9? This is 9.1.
Yes.
Okay, let me go to 9. That's good because that's the only one I'm gonna help you on right now. So, okay, we're looking for dogs, right?
Yeah, and I think I'm just confused. Oh, shoot, I lost it. About the 17%. Like, I don't know. Yeah, we can
Minus
just
the
go through it together.
71%. I don't know why I have this weird blue thing there. The 240 people were asked if they like dogs. 71% said they did. So 0.71 times. Well, see, the thing is, you don't need, uh-oh, exit page. No, I don't want to do that. Okay, let's go back. Doggone it. It's a funny question about dogs, and I say doggone it. I am a very goofball. All right. So basically what they're trying to do is they're trying to force you to do this one by hand instead of using your calculator.
Mm,
That's what's happening. So
mhm.
you would use your margin of error. So your 99% confidence level, find your critical value. So if you use 0.995 in your inverse norm, or look at the Z table, which I just got rid of, find out what that is. And then, so remember your standard deviation. So it's square root of P times 1 minus P divided by N. So you take the 0.71 times 1 minus 0.71 and divide it by 240. Find the square root. I'm going to write it down so that I could show you. So I'm going to get this 99% confidence level right here. 0.995. Okay. All right. So I would do 2.576 times the square root of divided by 240. All right, so this is what it would look like. So this is your margin of error right here. So this right here is the critical value. Z-score. I can't write score apparently.
And it would be 0.17, right?
Yeah, well, minus 0.71.
Oh,
Yours-
gotcha.
Yeah,
Yep.
mine's 0.71. Yours might be different, but this is just what mine is. These are my values. So everybody gets different numbers. And
Yeah.
then this right here is the P hat that they gave you. That's the P hat they gave you. And then this is your N.
Okay.
Yeah.
And so that, whatever I get from that is my margin of error.
Yes.
Okay.
Okay.
All right. Thank you.
Is anyone else already working on it and have any questions? All right. I'm going to stop recording, and then there's questions after that. You can have those.